So it is nothing but a combination of normalized resistance and reactance functions in the reflection plane. In the reflection plane, gamma. So it is a plot of, it is a combination, or it is constructed by using the normalized resistance and reactance circuit in the reflection plane gamma. Gamma can be written as it is a complex quantity, right? Gamma is a complex quantity ZL minus Z naught by ZL plus Z naught, right? So when these impedances are complex, gamma is nothing but a complex quantity, right? So gamma we can write it as gamma real plus J gamma imaginary, right? So gamma is a complex quantity, so gamma can be written as gamma real plus J gamma imaginary. So how this value will vary? This value will vary if you change the load impedance value. For a given transmission line, Z0 is constant. For a given transmission line, Z0 is a constant. If you change the load impedance value, ZL is nothing but the load impedance value. So for different values of ZL, we will get different reflection coefficient. So how these two are related? How these two are related? It is the representation in the Smith chart. How these two parameters are related with respect to each other is nothing but the Smith chart. So why it is useful means we have seen the low input impedance expression Zn is equal to Z0 into ZL plus if you take a lossless line it is J Z0 tan beta L by Z0 plus J ZL tan beta L, right? So input impedance you can find if you know the load impedance value and characteristic impedance value and the length of the transmission line, or any impedance on the line can be measured if you know ZL, load impedance, characteristic impedance and the length of the transmission line. So in order to find, you have to substitute in this formula. You have to find tan beta L value. Then again you have to substitute here. Again, this is in rectangular form. This rectangular form you have to convert it into polar form. Again, the denominator also you have to convert it into polar. And lot of calculation need to be done in order to find the impedance on the line. And then characters this reflection coefficient also. ZL minus Z0 by ZL plus Z0. So this rectangular form you have to convert polar form and again you have to do some calculation. So a lot of calculations are required in order to find the reflection coefficient and impedance values on the line. But with the help of Smith chart, we can easily find the value of impedance value. Impedance value, this is the useful part. So where we will use this Smith chart is finding impedance at a point, at any point on the transmission line. At any point on the transmission line, we can easily find the impedance. And similarly, we can find the reflection coefficient. Reflection coefficient also we can find. And if you find, if once we find the reflection coefficient, we can determine the standing wave ratio also. So whereas if you do mathematically by using these formulas, so these are complex expressions. So you need to do a lot of calculation. So earlier, when computers are not there, so by using Smith chart, it is very easy to calculate. But now computers are there, we can still calculate very easily by using programs. But in the very old days, Smith chart is the very useful part. Without doing all these calculations, we can easily find the impedance at a point on the transmission line and reflection coefficient and also the standing wave ratio. So these are the main useful things we can do by using the Smith chart. So it is a graphical tool in order to calculate the impedance at any point on the line and reflection coefficient and standing wave ratio. So it is a, from mathematical point of view, Smith chart. Smith chart is nothing but a simply representation of all complex impedances with respect to the coordinates defined by the reflection coefficient. As we have said, reflection coefficient, as it is a complex quantity, we can write it as real part plus j imaginary part. So for different values of load impedances, complex impedances value, we will get different reflection coefficient. So it is simply, Smith chart is nothing but a simply representation of all possible complex impedances. All possible complex impedances with respect to the coordinates defined by this gamma r and gamma I. It is nothing but x plus jy. So x-axis is nothing but this gamma r axis, and this y-axis is nothing but the imaginary axis. So this is the imaginary axis, and this part is real axis. So the reflection coefficient.
If you like the video, please share, like and subscribe. Hit the bell icon to get latest video updates.